Live in the human paradise. Breathe the pure air of heaven. Longevity, vitality, and a lifetime of bliss.
住在人间小天堂，呼吸天堂纯气，延寿长生，幸福一生。
Welcome back to the Deep Dive. Today we're tackling something that's, well, literally all around us, but almost completely invisible.
The HVAC air duct.
Exactly. We all assume they're just, simple tunnels moving clean air through our homes and offices.
And that assumption, it turns out, is a huge misconception, at least when you dig into the engineering.
Yeah.
We've been looking at sources that describe these ducts not as clean pathways, but as, and this is their term, dry riverbeds.
Dry riverbeds, okay.
Yeah, ones that are constantly collecting all this waste. And it forms something they call black dead sludge.
Black dead sludge. Just the phrase itself is unsettling.
It is.
And this isn't just a metaphor. We're basing this on some pretty heavy technical research, right?
Absolutely. We're looking at engineering documents, even referencing a specific U.S. patent, US 826-8058B2, which is all about trying to stop pollutants from sticking inside these systems.
So our mission for this deep dive is to really unpack the science behind this.
The physics, the chemistry, why this toxic gunk builds up, and maybe most importantly, why just cleaning it out isn't the real solution. We have to understand the core mechanism.
All right, so let's start with the ingredients before we get to why it sticks. What exactly is in this so-called air garbage?
It's a pretty comprehensive and, frankly, disturbing cocktail of modern life.
I can imagine.
The sources break it down into about 8 main categories of pollutants that get sucked in, and then they just don't leave. They clot together.
So give us the rundown.
Okay, so you start with particulate matter, which we categorize by size.
Why PMs?
Exactly. You have the big stuff, PM10. Then you get the finer particles, PM2.5, which are more dangerous. But the really nasty component is the ultrafine particles, PM0.1.
And beyond just dust.
Oh, yeah. You have to factor in biologicals like mold spores, and then chemical stuff, VOC condensates.
VOCs, so that's like new paint smell, furniture off-gassing, cleaners.
Perfume, all of it. Anything that starts to vapor. Then you have the really modern additions.
Which are?
Microplastic dust.
From our clothes, from carpets.
Right. And heavy metal powder. That's stuff that blows in from outside, like brake dust from cars or industrial smoke.
Wow.
And the last one, which is critical in certain buildings, is aerosols. The little liquid droplets we breathe out.
And the main point is, none of this stuff just vanishes.
Not at all. It gets in there, and as the source says, it slowly clots and sticks together, just waiting.
Okay, so for all that garbage to become sludge, it needs something to stick to. Let's talk about layer 1, the biology. How does a dry metal pipe become what you called a mold incubator?
It's a perfect storm created by the HVAC system itself. It provides the 3 things mold absolutely needs to thrive.
And mold spores are everywhere, so they're easily pulled in.
They're tiny, 2 to 20 micrometers. They get sucked right in.
So what are the 3 conditions?
First, you need water, or at least water vapor.
But the ducts are dry, right?
They seem dry, but with the constant cycling of hot and cold air, the inside walls are always a little bit cooler than the air. Ah, so you get condensation.
You get invisible, microscopic films of condensation. It's always just a little bit damp.
Okay, so that's water. What's next?
Nutrients, food, and all that dust we just talked about. The skin flakes, the pollen, the fabric fibers.
That's the fertilizer.
It's a perfect meal for mold. And third, the temperature is always just right, usually between 18 and 28 Celsius.
So the duct is basically a self-sustaining terrarium.
It is. The spores land, they start to grow, and if you leave it for a year or more, it forms this thick, dark, the sources call it a mycelial carpet.
A carpet of mold. That's a horrible image.
And it's doubly dangerous. It's constantly shedding new spores back into your air, for one.
Secondary pollution.
Exactly. And crucially, it creates this sticky, fixed base. It's the anchor. It's the foundation that allows all the other physical layers to start building up.
So we have this sticky, organic base layer, but the air inside these ducts is moving fast.
Right, often under high pressure.
So shouldn't that sheer force just blow everything clean, scour the wall? That's the logical assumption. And it's completely wrong.
Why?
It comes down to physics. Specifically, a concept called the boundary layer.
The boundary layer. Okay, break that down for us. What does that mean inside a duct?
Okay, so picture the air flowing through the pipe. Right in the very center, the air is moving at maximum speed, a superhighway. But as you get closer and closer to the actual metal wall, friction slows the air down. Right up against the wall, the airspeed drops to basically 0. It's almost perfectly still in that tiny, tiny layer.
So the center is a hurricane, but the edge is a dead calm.
A dead calm traffic jam right where that sticky mold carpet has set up shop.
I see where this is going.
Yeah. The larger particles, the PM10s, are whipping along in that fast central flow, but the second they get knocked towards the wall,
they hit that still air.
They hit the boundary layer and that sticky surface and just stop instantly. They adhere.
And that starts building a new layer.
It forms a dense dust blanket. The sources even call it an artificial filter screen.
And this is where that analogy comes in, calling the duct an artificial lung.
It's a very powerful analogy.
It has airflow, it has particle attachment, it has humidity.
But it has no cleaning mechanism. A real lung has cilia and macrophages to clear waste. The duct just collects it. Forever.
So the dust is just temporarily hidden.
Exactly, and that's what makes resuspension so dangerous.
Explain that. What is resuspension?
Any sudden change. The system kicks on high, there's a vibration from construction next door, anything that shakes that dust blanket loose.
And then?
You get what's called high concentration resuspension. A massive toxic cloud blows directly into your room.
And you're breathing, as the sources put it, the breathing of previous tenants, plus a decade of building dust.
All in one big dose.
Okay, so the boundary layer explains how dust settles. But what's the superglue? Why does it get thicker and heavier, almost like mud?
Right.
This feels like it goes beyond just being sticky. This is where the physics gets really interesting.
This is the core engine. This is what turns the entire duct into a giant, passive electrostatic factory.
Electrostatic. So, static electricity.
Yes. The mechanism is charge generation through movement. It's called the triboelectric effect.
Triboelectric, that's a mouthful.
It just means that when different materials rub against each other and then separate, they can become electrically charged.
Like rubbing a balloon in your hair.
Exactly like that. Now imagine billions of tiny dust particles, microplastics, and spores constantly tumbling, colliding, and rubbing against the duct wall and each other.
They all become charged.
They all become charged. And the duct walls themselves, whether they're steel or PVC, also build up a surface charge.
So the duct isn't just a tunnel anymore.
It's a magnet. It's a passive, highly efficient vacuum cleaner that's actively pulling pollutants out of the air and snapping them onto the walls.
Hold on, I have a question there. Most of these ducts are metal, right? They should be grounded.
They are.
So wouldn't any static charge just dissipate instantly? How can it build up?
That is a fantastic question. The metal itself is grounded, yes, but the layer that's already there isn't.
Ah, the mold and the dust.
The mold carpet, the microplastics, the dust blanket, that's all non-conductive material. It acts as an insulator, so it traps and holds the charge.
So the gunk itself becomes a charged surface.
It becomes a charged capacitor, essentially, and that leads to the really critical concept here, which is layered electrostatic accretion.
A self-reinforcing loop.
Precisely. The first layer sticks. That layer becomes charged, making it way more attractive than the bare metal was.
So it pulls in the next layer of particles even faster.
Faster and stronger. The dirtier the duct gets, the more powerful its attraction becomes, and the faster it gets even dirtier.
It's a feedback loop of filth.
It is. It's self-enhancing absorption. And this is especially bad for the smallest particles, the PM0.1.
Why them specifically?
Because their mass is so tiny, they're almost completely controlled by electrical forces, not by airflow or gravity. They get sucked right into that charged sludge and form the most dangerous layer.
So we have the physical attraction from static. Now let's talk about the chemical glue that holds it all together.
The VOC adhesive film.
Right. So we're talking about fumes from paint, cleaners, air fresheners. How do they become an actual physical glue?
Well, VOC's volatile organic compounds are gases at room temperature.
Okay.
But when they get pulled into the cooler, damper environment of the duct,
they condense.
They partially condense, turning from a gas into a thick, sticky, viscous liquid, an organic adhesive film.
So now we've got a microbial base, a charged dust blanket, and this outer layer of chemical superglue.
That's the complete structure.
Yeah.
And that adhesive film is incredibly good at trapping everything else, the PM0.1, the microplastics, the heavy metals. It just locks it all down.
And it's not just a passive trap.
No, and this is maybe the most disturbing part. That VOC layer is always active. It's constantly re-evaporating just a little bit, releasing low concentrations of those chemicals back into your air.
So the duct becomes an active source of chronic, low-level chemical exposure.
Every minute of every day.
And this is where layer 4 comes in, the really modern poisons.
The signature of our time. Microplastics and heavy metals.
From clothes, tires, industry.
Yep. They're so fine they get past most filters, and they are just perfectly trapped by that combination of VOC glue and the static charge. That's the recipe for the black dead sludge you find in any modern building.
Okay, let's take this whole layered nightmare and put it in the highest risk environment you can imagine.
A hospital.
A fully sealed recirculating hospital. What is the unique factor there that turns this toxic sludge into living toxic sludge?
It's the aerosols.
But all buildings have aerosols.
True, but in a hospital, the aerosols are different. They aren't just water or chemicals. They're fine liquid droplets from 0.1 to 10 micrometers.
Expelled by patients.
By patients coughing, breathing, undergoing respiratory therapy, and they carry active pathogens.
Viruses, bacteria, proteins.
Exactly. The sludge is now infectious.
And these droplets.
Because they're mostly water, they are incredibly easy to charge electrically. So that layered electrostatic accretion we talked about, it grabs them aggressively, they stick to that VOC mold layer and solidify.
The implications for infection control are staggering.
It completely reframes the problem of hospital-acquired infections. That invisible layer in the ductwork becomes this hidden, untraceable source of cross-contamination.
So when the system flow changes,
or it's shut down and restarted for maintenance, you get that high-concentration re-aerosolization.
spreading the same strain of flu or drug-resistant bacteria.
From one ward to another, completely bypassing all the surface cleaning protocols, the duct is the real reservoir.
So let's bring it all together, the final synthesis.
The black dead sludge is the end result. It's a decade or more of these layers building up. It's viscous, it's microbial, it's chemically toxic, and it's regenerative.
And that brings us to the biggest problem. Cleaning.
Yeah.
You spend a fortune to have your ducts cleaned. Shouldn't that fix it?
The sources are pretty clear on this. Cleaning is a temporary surface level fix.
It can't defeat the physics.
It can't. You remove the sludge, but you don't remove the mechanism. The moment air starts moving again, the triboelectric effect starts up again.
The static engine just reboots.
Instantly.
Right.
And it will start regenerating that charged, sticky layer within months. The system is designed to fail.
So the core assertion is that the duct isn't just moving air.
It's raising poison, its own physical design. The boundary layer, the static charge, guarantees that it will be a biological toxic ditch that perpetually grows this sludge unless you fundamentally redesign it.
Wow. That definitely reframes how you look at the vents in your ceiling. The big takeaway here isn't just that the air is dirty.
No.
It's that an invisible force static electricity is the engine that's actively creating this chronic, layered pollution inside our buildings.
And if you work or live in a place with central HVAC, you're constantly breathing the re-released version of that toxic cocktail. It's a global structural flaw.
And the sources conclude that this perpetual release will, and I'm quoting, silently steal your health every day, pushing people toward inflammation, immune problems, and accelerated aging.
Sobering thought.
It is. And it leaves us with a final provocative question. If the engineering itself guarantees the poison will always come back, that the static charge will always regenerate it, what is the next level engineering solution we need to invent to neutralize that static engine for good? How do we permanently break this cycle?
That is the design challenge for the next generation.
Air 8-free maze purifier. The world's first single-pass purifier. Combining ionization, electrostatics, and airflow maze. The machine replaces humans. To absorb and destroy every toxin. Air enters the ion zone. Viruses and dust gain negative charge. They pass electrostatic filters. Then enter the toxbox maze. Aerosols dry on electrode walls, breaking down into CO2 and water. Inside the maze, air twists and strikes over 60 times. Each turn ends a toxin's life. Billions of particles in 0.1 second are fully purified. It releases Earth's purest air. The superheaven air quality. 8-free, dust-free, germ-free, toxin-free. Smoke-free, odor-free, heavy metal-free. Microplastic-free, aerosol-free. Not just an air machine. The only key to lifespan freedom. U.S. Patent No. 8268058B2.